You've been told every object in space obeys one law: gravity decides where it goes. But last night, an interstellar object called 3I/Atlas appeared thousands of kilometers away from where gravity said it should be. Yet its motion, its brightness, and its timing line up less like a mindless comet, and more like a ship quietly changing course the moment we pointed our telescopes at it. That should be impossible. Space rocks don't flinch, don't react, and they definitely don't seem to notice when tiny primates on a blue planet start staring at them. Scientists at NASA, ESA, and Harvard are looking at the same data, and none of them can fully explain what this thing just did. So what is 3I/Atlas really? A bizarre chunk of ice from another star? Or a machine that just revealed itself by failing to hide perfectly? It started like any other minor alert. Atlas, the NASA-funded survey in Hawaii that scans the sky for killer asteroids, flagged a faint point of light drifting just a little too fast on a path just a little too steep. The Minor Planet Center ran the numbers, and one symbol changed everything. The letter I for Interstellar. This wasn't from our solar system. This was the third confirmed visitor from deep space, after Oumuamua and Borisov. NASA's Jet Propulsion Laboratory quickly generated an orbit. ESA's analysts checked it. At Harvard, interstellar object specialists pulled old survey images, searching for any sign of 3I/Atlas sneaking through our skies unnoticed. The first explanation sounded familiar and safe. A dark, icy comet from another star, venting gas in strange, lopsided jets. The second explanation stayed mostly unspoken, buried in private messages and late-night calls. Non-gravitational thrust that wasn't random. Something acting like a ship, not a snowball. Which story survives once you see how the data started fighting back? The first cracks appeared in the light curve. Teams using Hubble's old photometry catalogs and fresh data from observatories on 3 continents plotted 3I/Atlas's brightness over time. A normal rock tumbles and flickers. A fragile comet flares and sputters. This thing pulsed. Its light rose and fell in a slow, repeating rhythm, like a heartbeat in the dark. Too regular for a chaotic spin. Too stable for random jets of gas. Then its spectrum arrived, and the mystery deepened. Instead of clear signatures of water and simple carbon compounds, the surface looked almost unnaturally clean. Darker than charcoal, yet with sharp, mirror-like reflections at certain angles. One lab compared it to oxidized metal. Another said carbon-rich glass. If 3I/Atlas was really venting gas, where was the fuzzy coma every comet grows as the sun cooks its surface? And if it was solid and inert, what invisible hand was pushing it off course? Just enough to wreck our predictions. That's when the orbit started misbehaving in public. The Minor Planet Center's official ephemeris updated, then quietly rolled back, then updated again. Amateur skywatchers began saving every version, lining them up side by side. Same observation times, slightly different coordinates. For a while, a whole block of astrometric measurements simply disappeared from the public listing, only to reappear later with inflated error bars. No dramatic announcement, just silent edits, as if the math itself refused to sit still. At NASA's Jet Propulsion Laboratory, people spend their lives modeling tiny non-gravitational nudges on spacecraft, sunlight pressure, outgassing, microthrusters. They know exactly how a soft, continuous push looks in the residuals. Yet public statements stayed bloodless and vague, hinting at additional forces while avoiding the one comparison everyone was thinking. Meanwhile, observing proposals mentioning 3I/Atlas began circulating for JWST and ESO's Very Large Telescope. And on the Deep Space Network schedule, observers spotted an oddly timed block of antenna hours labeled Only Calibration, overlapping the object's closest passage through the inner system. By now, the clock was screaming. Each night, 3I/Atlas fell deeper into the sun's gravity well, and the window to study it slammed narrower. Refined orbits showed it threading a narrow corridor between Earth's and Mars's paths, hugging the flat plane where almost all our spacecraft live. A natural fragment should whip around the sun in one smooth, predictable curve. Instead, some teams reported that the residuals hinted at segmented changes, little jumps, as if a series of taps kept nudging it back onto a chosen track. And right as it crossed the line of sight toward Earth, its brightness spiked, as though a flat reflective surface had turned to face us for a moment, and then turned away. Harvard's Interstellar Object Group noticed one more chilling detail. Its incoming speed didn't match the gentle flow of nearby stars, as if it had been wandering the galaxy for ages only to arrive now, when we can finally watch it twitch against gravity. So what do you think 3I/Atlas really was? Exotic comet, derelict relic, or active probe? And which answer are you brave enough to put in the comments right now, honestly?